Welcome to Vagdevi College of Engineering, Department of Computer Science and Engineering. Our subject Compiler Design Lab. Here we are going to learn write a C program for lexical analysis. What are the objectives of this Compiler Design Lab? To provide an understanding of the language, translation peculiarities by designing complete translator for mini language. The outcomes of this laboratory: students will understand the practical approach of how a compiler works. This will enable him to work in the development phase of new computer languages in industry. The outline of this course, of this presentation is: what is lexical analysis? What is the role of lexical analysis? What is the function of lexical analysis? What are major terms in lexical analysis? A sample code to identify tokens, lexemes, pattern. Here we are also going to see an algorithm and the code execution of lexical analysis. Lexical analysis recognizes the vocabulary of the programming language and transforms a string of characters into a string of words or tokens. Lexical analyzer is also called as scanner, is a program that performs lexical analysis. Lexical analysis discards the white spaces and comments between the tokens. What is the role of lexical analyzer? It is the first phase of a compiler. What is a compiler? A compiler is a system software which converts high-level language into machine-level language. High-level language is a English-like language which we write a source code. And a machine-level language is a low-level language which is easily understandable by the system. The main task of lexical analysis is to read a stream of characters as an input and produce a sequence of tokens. Here we are displaying a structure of the lexical analyzer, how it is going to read the character and how it generates a token. The lexical analyzer reads the character from the input and it generates tokens as an output. These tokens are input for the next phase of a compiler called parser. What are the functions of lexical analysis? It reads text character by character, eliminate the comment line, eliminate the white spaces. It converts lexemes into tokens. It creates a symbol table and insert tokens into a symbol table, generate errors, send tokens to parser. The major terms in lexical analysis are token, pattern, lexemes. Token is a classification for a common set of strings. Examples: identifier, keyword, number, so on. And the pattern are the rules which characterize a set of strings for a token. Examples: a regular expression where it's going to matches and identifies it is a token, what type of token. Lexemes The actual sequence of characters that matches pattern and is classified by a token. Examples: X is a variable, int, count, name, a, 10, etc. These are the sequence of characters, a set of characters which treat each and every set of characters as one lexeme. Here is a sample code to identify tokens, lexemes and a pattern. Here we have taken a a maximum function of integer data type by passing the two parameters a and b of integer data type. If a is greater than b, then return a, else return b. In this sample code, int is a lexeme, max is a lexeme, open parenthesis is a lexeme, int is a lexeme, a is a lexeme, comma is a lexeme, so on. So each and every set of characters treated as an lexemes. Now these lexemes are characterized what type of token it is. Here we had example, int is a keyword, max identifier, open parenthesis, int keyword, so on. Now here we are going to see write a C program to implement a lexical analysis. Before going to a program, let us see what is an algorithm of this lexical analysis. Declare an array of characters, an input file to store the input. Read the character from the input file and put it into a character type of variable, say C. So C is a character type of variable which reads each and every character from the input file, and then we are going to check the conditions as if C is a blank, then do nothing. It means that it's in a white space. We need to eliminate the white space. If C is a new line character, increase the line number. If C is a digit, then set token value, the value assigned for the digit, and return it as a number. If C is a proper token, then assign the token value. It may be an identifier, it may be a keyword. In the next, we are going to see an execution part of this lexical analysis. Lexical analyzer performs a task of identifying different tokens such as keywords, numbers, special characters, identifiers, etc. Here we have declared three file pointers f1, f2, f3. f1 is used for storing input, f2 is used for storing identifiers, and f3 is used for storing special characters. Here, by using fopen function, we open a file of input in a write mode. By using a C variable, each and every character from the input file which has been stored in F1 is read by using a getChar function into a variable called C, and the character stored in a F1 file pointer by using a putC function. Now the F1 file is opened in a read mode, and the F2 file is opened for an identifier in a write mode. F3 file is open for a special character. The following loop is written to identify special characters and identifiers and write them in a respective files. Now we are going to read each and every character from the F1 file which already it is open in a read mode. By using getC function, we reads a character and we stores it in a variable called C. Now we are going to check if character is a digit, then it prints, it processes the particular logic and it prints it as a number. If C is not a digit, then it may be an alphabet. If it is an alphabet, then again it checks what type of alphabet it is. It means it may be an identifier, it may be an keyword. If C is an empty space, then it doesn't print anything. If C is a new line, it increases the line number. Here if C is an identifier, it puts into an F2 file. If C is an special character, then it puts it into an F3 file. Here we have written a following loop which is used to print the numbers given in the input. Already we have said that F2 is a file open for an identifier. Now in a F2 we have stored the alphabets and we are opening the F2 file in a read mode, and we are going to check whether it is a keyword or an identifier. This is a following loop to print the keywords and identifiers which is present in the given input. If it is a keyword, then it compares each and every string within a keyword and it prints it as a keyword. If not, it prints it as an identifier. Now the F3 is a file opened for a special character in a read mode. Each and every special character is going to be read by using a getC function into a C variable. Now we are going to check whether it is a special character or not. If and then the last one is the total number of lines. If C is in a new line, then it prints to a total number of lines. Here we are going to execute the code. To save the program, given a Alt F yes key or else Alt F save, and to compile Alt F9, check whether you have any warnings or errors. So here we don't have any warnings and any errors. The next, run the program by using a control F9. So here it is going to ask, enter the C program. You may enter the code from the cursor itself, or else you can give a new line. If you give a new line, it counts that particular line also. Now I am writing a sample code as main function, open the parenthesis, and I am declaring a 3 variables of integer data type called A, B, C. Give a semicolon, and here I am assigning A is equals to 5 and B is equals to 2. Now I am giving an expression called C is equals to A plus B, semicolon, close the parenthesis, press on a Ctrl Z and enter. Now again perform the run function called as Ctrl F9. Now we are going to see the output of this code. The numbers in the program are 5, 2. Commands are main is an identifier, MAIN is treated as an lexeme and it is an identifier. Int is a keyword where we have given within the keyword function, keyword program to compare the each and every characters. A is an identifier, B is an identifier, C is an identifier. Again we have declared A is equal to 5, so again it is treating A is another lexeme, it is an identifier. The same way B is another lexeme, is an identifier. C is another lexeme, is an identifier. Again A and B is also an identifier. And special characters which we include are open parenthesis, simple parenthesis and the close simple parenthesis, flower bracket, comma, semicolon, equal, plus, again semicolon, closing the parenthesis. Now it is going to count the total number of lines. Main is the first line, open parenthesis second line, int ABC is the third line, A is equal to 5 is the fourth line, B is equal to 2 is the fifth line, C is equal to A plus B is the sixth line, closing the parenthesis is the seventh line, and the line which you have started at the end of the C program, you have given new line. That line is also going to count as an eighth line. Thank you.